Alright, so let's finish up this section. This is the last page. So we just want to use our sum and difference formula to verify our identities. So we're going to use the same techniques as before, prove that each is an identity. So we're going to choose one side to change. Typically you want to choose the most complicated side. So I'm going to work on changing sine of pi over 2 minus x and show that it equals cosine of x. Alright, so this is actually a co-function identity that we mentioned a long time ago at the beginning of this section. Okay, so I see subtraction, so that means I am going to use my difference identity for sine. Do we remember what that looks like? Sine of the first one, cosine of the second one, minus cosine of the first one, sine of the second one. And so this should equal cosine of x. Alright, and so all I did was use the difference formula for sine. Alright, well notice sine of pi over 2, I know exactly what that is. Sine of pi over 2 is 1. And cosine of pi over 2 is 0. And so you could have figured this out using the unit circle, or you just knew these values already. Alright, so what's left? Cosine of x equals cosine of x. Done. We verified this identity. So this is true. Alright, let's look at the next one. Alright, so we got sine of x plus y minus sine of x minus y equals 2 cosine x sine y. Alright, so I already know I'm not going to have enough space to write both sides, so I'm just going to change the left side. Alright, and I am going to use my sum formula for sine as well as my difference formula for sine. So remember, it's sine of the first one, cosine of the second one, plus cosine of the first one. Sine of the second one. Minus, I'm going to make sure I put in parentheses so that I'm subtracting the whole thing and I don't mess up with my signs. Difference formula for sine. So it's similar. Sine of the first one, cosine of the second one. This time we do minus. Cosine of the first one, sine of the second one. Okay. So that is just me expanding the first part, or the left side, using the sum and difference formulas. Next, I'm going to just distribute this negative right here. Okay, so I should notice that some of these things look alike. I think I have two of each thing, so I'm just going to combine like terms. So I have a sine of x and a cosine of y. So where else do I have sine of x, cosine of y? Right here. I'm adding one and I'm subtracting one, so that's going to go to 0. So that's going to go away. And then I have a cosine of x, sine of y, and another one. So that means we have 2. Cosine of x, sine of y, and that's exactly what we needed to verify our identity. Okay. All right, let's look at the last one. All right, so this says tangent of pi minus x equals negative tangent of x. Okay. Over here, I see subtraction, so I can use my identity for tangent. We haven't used this one a lot today, so it may not be fresh on your brain. All right, so we want to use subtraction, tangent, so that means we need to take tangent of the first one minus tangent of the second one divided by 1 minus tangent of the first times tangent of the second, and that should equal negative tangent x. So this is the difference formula for a tangent. Okay. All right, now let's evaluate tangent of pi. Well, if you, tangent of pi. Well, if you remember, sine of pi is 0, so tangent of pi is going to be 0. 0 minus tangent x over 1 minus 0 times tangent x. So this was just the unit circle, or just knowing. All right, and so we got tangent, negative tangent x divided by 1, which equals negative tangent x. And that's exactly what we were looking for. All right, so how do you feel about this section? Can you apply the sum and difference formulas for sine and cosine? You will need to know these on your own for the test. Can you apply the sum and difference formulas for a tangent? Are you able to use the sum and difference formulas to verify your identities? All right, that is all. If you have questions about this, make sure you ask me in class. Have a good day.